Alright, so first we need to start off by reviewing a little bit of derivatives, since antidifferentiation or integration is the opposite of a derivative. Okay, so what we've got here is the derivative of this function is equal to, we take the derivative of x first. So what we've done is we've got a constant a and we've got a constant c. This constant right here, we bring down a, x, and then when you take the derivative, what you're actually doing is subtracting 1 from the power. So there's an understood 1 here, so that's 1 minus 1, and that equals a times x to the power 0. And of course, x to the power 0 is equal to 1, so this whole thing compresses into just a equals a. Okay? Now, if this is the case, then what we're saying is that the derivative of a, the opposite, if I start off with this function and work my way backwards, then the derivative of a dx is equal to, as you were, is equal to, and it will get our original function back, ax plus c. Now the c, of course, is a constant that we don't know what it is. Okay? Now looking in a more general way, for a more generalized rule, the derivative of any function, where I have ax, where I have any function, so basically any power we can go back 1 and add 1 to it, okay? Where n is the original function, or is the original power, I should say. The derivative of this whole thing is going to equal a x to the power n. So again, working backwards, because we're doing the opposite, if I want to find out the derivative of ax n dx is going to be my function here. Okay, is going to be ax n plus 1 over n plus 1. And this is the general rule that we'll use to find most derivatives. Okay? Now, in the book, they do just add the qualifier that n cannot equal -1, because at that point it would be an undefined function, because if we have a 0 on the bottom, anything divided by 0 is 0. So we just can't do that. So we're going to always make a rule that n cannot, whatever's on the bottom of this cannot equal 0. Okay? All right. So, if I have an example, if we want to use numbers, I can say the antiderivative of 3x squared plus 4x plus 5. Now I'm going to apply this rule to everything there. I'm sorry, and I should say dx. Okay? Because you just notice that, and it's just part of the notation that you use that dx there is going to equal. So I'm going to take this, and I'm going to apply this to it, and I'm going to say, so basically what we're trying to find out is, this is the derivative of what function? So what was the original function that we started off with in order to get this? So if we have this as the derivative, what we can do is, working backwards, we go x cubed plus 2x squared plus 5x plus c. So how do we get all those? Well, we just work backwards. So basically what we did from here is we started with this, we add 1 to that. We added 1 to the power, so 2 plus 1, that gives us our 3 right here. Now, how do we end up with nothing there? Well, what we did was we multiplied that whole thing by 3, because if you notice here, you divided by n plus 1, and in this case n plus 1 is 3, so there's an imaginary 3 here, and then n plus 1, which is 3, and these cancel out. That's why we don't have anything there. Okay? Now in this case, my n plus 1 is going to be over, so this was 4 originally, and we had a n plus 1 is 2, so that was over 2, so that means those cancel out, and that's where it gives us the 2. The 5, we had the x2 because it's just a constant in this case, so we don't have an a per se here, so all we do is we chuck on that x to that plus c. So in the end, the antiderivative of this whole function is x cubed plus 2x squared plus 5x plus c. Don't forget the plus c. Okay? Doing another example, if I have it's not responding. Hopefully it'll start. Thank you. Another example is if I have the function and I want to find the antiderivative of x cubed, as you were, sorry. I have 3x squared plus 4x plus 5 dx. Now I'm going to take each of those terms and I'm going to add 1 to that and divide it by n plus 1. So in this case, n plus 1 is going to be 3. So again, I'm going to end up with x cubed because my n plus 1 is 3. So I've divided that by 3 and I get 1. So that's an imaginary 1 there. Plus, now, for this, n plus 1, this is 1, n plus 1 is 2. So I'm going to have 4 over 2, which is 2x, and then that's going to be squared because n plus 1 is 2, plus 5x, because in this case, again, I don't have that a, but I do have the n plus 1, so here I don't have an x at all, so n plus 1 is going to be at least 1, so that's where that x is. Okay? So that's all the derivative, those are the derivatives of those functions. So, let's have a look at a couple of them. So if we want to find the antiderivative of 2x to the power 7. So in this case, y is equal to 2x to the power 7. So to antidifferentiate, or to find the integral, we're going to use our nice family squiggly thing here. 2x 7 dx. Okay? Now what I'm going to do is, again, I'm going to apply that n plus 1 divided by n plus 1. So I've got 2x n plus 1, n is 7, so 7 plus 1, all divided by 7 plus 1 dx, which gives me 2x to the power of 8 over 8, which simplified gives me 1/4 x to the power of 8. Don't forget the c. Okay? So answering my original equation, the the integral of 2x to the power 7 is 1/4 x to the power 8 plus c. Okay? All right, next worked example. I've got 4, oops, don't do this to me. I've got 4x to the power of negative 3. 4x to the power of negative 3. Now, that means y is equal to, and we could write this another way. We could say that this whole thing is equal to x, or 4 over x to the power 3. Okay, they're pretty much the same thing. I don't necessarily need to do that. I'm just going to do the integral of 4x to the power of negative 3. Don't forget the dx. Okay. Now, n plus 1 is going to be negative 2. So I'm going to go 4x negative 3 plus 1 over negative 3 plus 1 dx. That gives me 4x to the power of negative 2 over negative 2. So simplifying this again, I have 4 divided by negative 2 is negative 2, x to the power of negative 2, and then I need to put that plus c, not dx. I need to erase. It's just taking me a little bit of time. I might try this at home with my faster computer. Okay? Now, the book will have it, and again, just like I said at the beginning, I could put this over there. I could have negative 2 over x to the power of 2. It's the same thing. Plus c. Okay? Now, I'll go ahead and work. If I have the function y is equal to 3 over the square root of 3x. Okay? Again, when I find the integral, what I'm really trying to find is if I'm making a statement that's saying that actually this is the differential of an equation that I don't know what it is. So I need to find y. Y is equal to that 3 over the square root of x. Now I'm going to rewrite this to make it easy because I can't really do anything with that when it's under there. Don't forget the dx, by the way. So I'm going to say the integral of, and I've got 3 over x to the power of 1/2, because I can rewrite that as 1/2 dx, is equal to, now I've got to take n plus 1. So I've got, here's my n is 1/2. So in this case, n is equal to 1/2. So I'm going to do n plus 1. N plus 1 in this case is going to be 1.5. So I've also got to divide that by 1.5. So don't forget about dividing it by, as you were, 1/2. And I apologize. Sorry, this is supposed to be negative 1/2, and that's supposed to be n is equal to negative 1/2. So n plus 1 is not going to be 1.5. My apologies. It's actually going to be 1/2. It's going to be 1/2. All right, so that does change things somewhat.